Hello and welcome back to AP Pre-Calculus. Today's lesson is 1.11, Equivalent Representations of Polynomial and Rational Functions. All right, remember, when we have a rational function, we have a polynomial function in the numerator and the denominator. And if I get a 0 in the denominator, then one of two things will happen. I'll either get a vertical asymptote or a whole. So what we're going to do is we're going to write this H equation in a new form. And then we're going to state whether they have wholes or vertical asymptotes. All right, so the first thing you want to do is to factor. Back in Algebra 2, I told you factoring does not go away. We got to factor, factor, factor. So if I factor this h of x function, the numerator is going to be x plus 2 and x minus 2. The denominator will be x plus 2 and x plus 5. Hopefully you guys remember how to do that, okay? So that is the factored form, right? So what we could do is to simplify that. We could cross these guys out. Well, what does that do when I can cross them out? That makes a whole. So we have a whole at x equals -2. So it would be -2, comma. Well, let's put -2 into what's left over. -2 minus 2 is -4. -2 plus 5 is 3. So I get -4 thirds. So that's where my whole is. And I still have an x left over. So I have a vertical asymptote, set it equal to 0 at x equals -5. Example 2 wants my domain. And I need to take out the -2 and the -5 from my domain, but all other numbers are good. So how can I write that domain? Well, starting on the number line, I start at -infinity, and I move along until I get to the first number I removed, which is -5. And then -5, keep going until you remove another one, -2, and then -2 to infinity. And we put parentheses around all these because I'm not allowed to have any of those numbers. And I put a little union sign in there. So that's how we would write the domain. All right, let's try it again. Let's go ahead and factor. So we have x minus 4 and x plus 3 on the numerator. We have, got to take the x out. And let's see what we got there. Let's go x plus 5 and x minus 4. Okay, so do I have any zeros of the function? That means where does my numerator equal 0? Well, to be honest, before I do that, I'm going to kind of cross things out because I don't have a 0 at 4, but I do have a 0 at -3. So I have -3 comma 0 because that would make a 0. Do I have a whole? Well, I did just cross things out, so I have a whole at 4, and let's put that 4 in and see what we have left over. I have 7 on the top, and then I got a 4 times a 9 on the bottom, so that looks like 7/36, right? Do I have any x's left over for vertical asymptotes? Well, I actually have 2. I have the GCF, which will give me x equals 0, and then the other factor gives me x equals -5. How about horizontal asymptotes? I actually go back and look at the original function for my horizontal asymptote because I'm looking at the first term, the degree of the numerator and the degree of the denominator. And I end up having this, x squared over x cubed. And if you remember what I said, I like to do the division. If I have an x left over, I have a horizontal asymptote at y equals 0. I should say, if I have an x left over in the denominator. If I have an x left over in the numerator, I don't have a horizontal. All right, the domain. I had to take out 3 numbers. I had to take out 0. I had to take out, let's write that down. I had to take out 0, -5, and 4. So I'm going to start with -infinity. What is the first number I get to moving left to right? That's -5. I'm going to union that with -5 to the next number, which is 0. Union that with 0 to the next number, which is 4. And then union that with 4 to infinity. And there's my domain. Now I know that G says use your graphing calculator, and I do want you to use your graphing calculator, but let's go ahead and put some things that we already know on here. I know that I have 2 vertical asymptotes at 0 and -5. 1, 2, 3, 4, -5. I know that I have a horizontal at 0. And I also know that I have a hole at 4 and then just a little bit above it. So 1, 2, 3. So there's like a hole right there, right? Did I forget anything? I think I did. I have a 0 at -3. So we can go over here. 1, 2, at negative. We can put a little dot right there. Notice that I'm actually touching the horizontal asymptote. That is allowed because a horizontal asymptote is talking about end behavior. What are your arrows doing as you approach negative and positive infinity on the x-axis? Doesn't really care about what's going on in the middle. It's not like it's making zeros or anything. Vertical asymptotes, they're a no-go range. You cannot touch those. Holes, you cannot touch them because we make zeros in the denominator. But a horizontal isn't making a 0. It's just telling us what our end behavior is like. Okay. Now we can go ahead and throw it into our graphing calculator and see if we hit some of the good things here. And hopefully your graph on your graphing calculator looks something like that. Okay. All right, now we're given a graphical representation that we have to try and write a function for. Let's go ahead and write down all the different things that we see. I see a 0 at, what is that, 3? At x equals 3. I have a hole at x equals 4. I have a vertical asymptote at x equals 2. Holy crap, I have a horizontal asymptote at y equals -1. I think that'll do it. Boy, there's a lot going on in this one. So let's see if we can figure this out. So we're going to put f of x here equals. The 0 means I have to have an x minus 3 in the top with nothing to cross it out in the bottom. That needs to be there for sure. The hole means I have to put an x minus 4 in top and bottom. Well, what is going on there? X minus 4, there you go. The vertical asymptote says we have x minus 2 all by itself in the bottom. And then I need to have a -1 for my horizontal, which means the degree in the top and the bottom had to be the same. And if you look at it now, the degree in the top is x squared. The degree in the bottom is x squared. Because if you FOIL those out, you'd have x squared's top and bottom. So the only thing I need to do is make it a negative because it moved down 1, right? And then the only thing I have to worry about is that this hole is really like 4, -1/2. We got to make sure that we can make that -1/2 when we put a 4 in. So kind of lightly cross those out and put in a 4. And if I put in a 4, I get 4 minus 3. That's 1. Make it negative, -1 over 4 minus 2. So that worked out. All right. So there is our function. All right, go ahead and pause the video and write down all the stuff we know over to the side, and let's see if you can get the function. All right, there's the stuff that we know from the graph. Let's see if we can put it into our g of x function here, okay? So there we go. Let's start with the 0. I definitely have an x minus 1 on top, for sure, right? A hole at 2, so that x minus 2 has to be on top and bottom, right? Vertical asymptote at 0. Whenever you have a vertical asymptote at 0, that means x must have been a GCF, so we're going to throw that out there. And also at 3, so x minus 3. And the horizontal asymptote says that my numerator degree has to be smaller than my denominator degree, and I have 2 x's in the top, 3 x's in the bottom, so that's x squared over x cubed, so I met that part. The only part that I'm worried about is that 2, 1/2, right? So let's go ahead and cross out these 2's real quick, and let's put it in there. Let's see, I got 2 minus 1 is 1 on the top, 2 times 2 minus 1 that's going to, 2 minus 3 is negative 1. That's going to give me negative 1/2. I need to make it positive 1/2. So if I put a negative out in front there, that will change it up, and that should be it. Okay, recall from an earlier lesson that we have a thing called a slant asymptote, or maybe sometimes called an oblique asymptote, when the degree of the numerator is exactly 1 more than the degree of the denominator. So take a look at this function k down here, right? If I factored it all out, you see that I have a whole at 2, I have a vertical asymptote at negative 1, but notice I don't have a horizontal. I do have this slant asymptote, right? And they told us that over here that it has a slant asymptote at y equals x plus 1. Slant asymptote means it's a line, right? So where did they get this from? Well, they did long division, okay? And we only have to do long division when the numerator degree is exactly 1 more than the denominator degree. So it's not that hard to do. So let's, on the next page, we'll see how to do it. All right, so if you remember, in long division, a lot of times we get a remainder, right? Turns out that when we're looking for a slant asymptote, we don't really care about that remainder all that much, okay? So let's go ahead and just look at the old school. How did we do long division back in 3rd grade? We put the 676 on the inside, put the 21, and we started out with going, say, hey, can 21 go into 6 right here? And we would say, no. So we move over and say, can it go into 67? And we say, yes, it goes in 3 times. And we put the 3 above there. We wouldn't put it above the 6 because 21 didn't go into 6, all right? And then what's that, 63, do the subtraction, 46, and we go, can it go into 46? We say, yeah, 2 times, and that'd be 42, and we have a remainder of 4. So we got 32, remainder 4, and we would write it like this, 32 and 4 21sts. So polynomial long division is different, but it's also kind of the same. We're going to put our nice big fraction, no, not fraction, our division thing there. We put our 2x plus 1 on the outside, 6x squared plus 7x plus 6. And I'm going to say, can a binomial, 2x plus 1, go into a monomial? Can it go into just that? And we go, no. So we'd move over to the 7x. And what we only care about is making that first term go away. We can have stuff left over under the 7x. We cannot have anything under the 6x squared, though. So I'm going, what can I multiply 2x by to turn to the 6x squared? And I go, oh, that's 3x. And then we distribute, kind of like we did over there, right? So I get 6x squared plus 3x, right? And we have to subtract these. So you can put parentheses out front and put the minus sign, or you can just go ahead and change these signs, right? And my 6x squareds cancel out, and I get 4x. Bring down the plus 6, and I only care about the 4x. I can have remainders, it's okay. So 2x times what will make 4x, and we go, oh, that's just a 2. And then we distribute, plus 2, change those signs, add them together. Notice the 4x's cancel out. I'm left with 4. So I'm left with 3x plus 2 is the quotient. My remainder is 4. And we could write this 3x plus 2 and 4 over 2x plus 1. But again, when I'm trying to find a slant asymptote, I really only care about this part, right? If it was a theoretical math question where I said, hey, just do the long division, you'd need to give me all of it. But if I'm looking for the slant asymptote, it's just the linear part of that. So go ahead and pause the video and give this one a shot. All right, I'm going to move over 2 terms because it's a binomial. And I'm going to ask myself, 2x times what will give me 6x squared? I'll put the 3x up there, distribute it to both terms, 6x squared plus 3x. Let's go ahead and change those signs because we want to subtract. And then I get negative 2x, bring down the plus 5, do it one more time. I have to just multiply by negative 1. That gives me negative 2x minus 1. Change the signs. together, and I get 6. What is that? 3x minus 1 plus 6 over 2x plus 1. So if I was looking for the slant asymptote, I would say y equals 3x minus 1. Also, if you remember from the beginning when I told you about how to look for horizontal asymptotes, when I said take your first term and actually divide them, notice I get 3x, right? So that kind of is helpful. I just don't know what the y-intercept is, so to get the y-intercept, I have to do the long division, but I knew the slope was going to be 3x, well, 3. All right, we're looking for a lot of things here on example number 7. I can look at this function and tell you that we are going to have a slant asymptote, but I'm not going to do that first. I'm actually going to factor. I always love factoring everything first. So when I factor this, I'm going to get x plus 6, x minus 2 on the top. On the bottom, I'm going to get x plus 6 and x plus 1. All right. Oh, I see x plus 6. I have a hole, right? So really, I can kind of cross those out right now if I wanted to. So there's my factored form. The vertical asymptote, I have one at x equals -1. I don't have a horizontal asymptote. We have a slant. Can't have both, so none, right? So my slant asymptote, I could cross these out if I wanted to, right? I would have to redo the thing. So I could go, all right, x squared minus 2x, and then x plus 1. I'm kind of missing something underneath the division symbol. I need to go all the way to a constant, so we have to put the 0 in there. That's called a placeholder. You're never allowed to jump a term or leave out a term. You have to start with your biggest exponent and go all the way down to the constant. So if there's not a constant there, there always is a constant there, by the way. You put plus 0, okay? So then I go over here, I put my x, I multiply x squared plus x, change the signs, get -3x, bring down to 0, and then I put -3, and I'm not even going to do any more because that is going to be my slant asymptote. So I go y equals x minus 3. See, I told you the long division for doing a slant asymptote a little bit easier because I don't have to go all the way to the end. I just need to make the y equals mx plus b, and I did that there. And if you're saying, well, why don't you just do the long division with the original? You could have. You're going to get the exact same thing. I just think it was a little bit easier to do it with smaller polynomials, but you definitely could have done it from the beginning. All right, so example number 8, we have a multiple choice question. Remember, we have a lot of multiple choice questions on our final exam for the year. So we got to find out this graph. Does it have horizontal? Does it have hole, vertical, slant? What's going on here, okay? So the first thing I notice is they did not factor the denominator for me. So I'm going to write it down here in factored form. I'm just going to go ahead, not even write the squared. I'm going to write it out there twice. You could write x minus 1 squared, but I'm going to cross these out because I have a hole at 1. Do I have a hole anywhere else? So I have one hole. This one says no holes, so it can't be this one. This one doesn't even say anything about holes, so it can't be that one. So now I'm already down to, if I had to guess, I'm down to that. So what's left here? Well, one says I have a horizontal, one says I have a slant. Well, if you look at your degree in the top, I have 2 x's, that'd be 2x squared. You don't have to do the whole thing. On the bottom, I have an x. Well, that's a slant, right? So my answer has to be C. All right, last example. They want us to sketch a function that would meet all of these limit notation properties, okay? So the first two talk about x going to negative and positive infinity. That means that we're talking about end behavior. And I know from here must be going up and down, right? And then the second one, I'm approaching -1 from both of those. So that tells me that I have a vertical asymptote at -1. All All right, so I'm going to deal with the vertical asymptote first. They're both going down, right? So I know that it has to be something like this. But as I go to positive infinity on my x-axis, I'm going to negative infinity. So it must be doing something like that. And if I go to negative infinity, I'm going to positive infinity. So that might be what the graph looks like. All right.